Hi, welcome to this lecture. In this lesson, we will see how to calculate the normal distribution and understand the different values that we saw in the lectures before. So, for the sake of that, I'm importing certain libraries as shown here. I'm going to make use of Pandas library, SciPy, Matplotlib, or few of the libraries which I need to be importing it. So, to import that, just select all these lines and execute selection in console. So once these libraries are imported, the first thing I am doing is reading my input data. So the input data I am having in this case is contained in a CSV file. So I am making use of the pandas libraries pd.readcsv function and then importing the file. If you are going to use a Windows PC, then take care of to change this path with the drive letter as well. Okay. So now I've got this into the data frame called as MBA. To analyze the first few lines, I can give MBA.head 5. So then the first few lines will be printed in the console window. There are three different columns: data, serial number, work experience, and GMAT. I'll be mostly interested in analyzing this GMAT column. This represents the GMAT score, what the students has scored in their exams. Okay. First, we will visualize it in the form of a histogram. So there is a function called as plot. So this is the matplotlib.pyplot library. Matplotlib.pyplot as plt using the alias name I have imported. So plt.hist. This represents the histogram plot, and this is the data I'm going to plot it in histogram. So what should be the face color? What should be the distance between each and every bar graph? That is represented in the alpha value of 0.5. So this is the histogram that produces. This shows my data is not perfectly of normal distribution, but slightly it is skewed towards right, and my average value is somewhere between 700 to 725. This is the understanding that gives us based on this histogram visualization. Now let's see the quantitative measurements. MBA.skew to measure the skewness value. This just says the score of GMAT value is minus 0.5, meaning the GMAT score is little bit negatively skewed. The graph appeared to be positive in nature, but the skewness measure shows it is 0.5. That means it is negatively skewed towards left. Okay. Next, the kurtosis score. The kurtosis score for GMAT, it is 1.16, meaning the graph is less than normal value of height. So this is 1.16. It shows it is. If we take the case of work experiences, it is too high, which is definitely not normally distributed. So that is the idea of what the skewness and kurtosis are giving us. This is another way MBA instead of GMAT. So that is going to produce specifically the score for GMAT and specifically for kurtosis for GMAT. So either of these commands we can use. Both are going to give us the same result. I did not use the print command here. That is why the result did not print it in the console. Okay, that is correct. The other way, the final way in which we can check the normality is using this QQ plot. So to calculate the QQ plot, again there are two different ways in which we can calculate the QQ plot. There are multiple libraries. So one is making use of stats library, stats.probability plot, and inside that we are going to give this normally converted values which is stored in the variable measurements as the input here. Distribution is normal and plot is PLT library. So this np dot, this is numpy library, np.random.normal. I am generating for 20 different locations. Scale is 5 and size is 100. So 100 different points. This particular normal line will be produced. For this normal line, I am going to plot my data. So let me see what the curve gives us. So this is how the plot is. So we can see our calculated data is almost along the 45-degree angle, such that this is normally distributed. We can safely assume it. The other plot is we directly make use of the stats models.graphics.gof plots import QQ plot. So QQ plot is a library which we need. So this is actually present in this package, and we are taking the package. And inside this QQ plot library, we are supplying our data for which we have to calculate the QQ plot. And the line is named as S line, so that it will produce a continuous line. When I select this and execute, I'm getting a uh, straight line of values. So this is straight line and this is the straight points in which my data is plotted. So it is approximates and prints in the straight line. That is why the curve is coming in this way. I gave a slightly different explanation. These two ways of plotting are in fact for qplot, but the data are different. This second kind of plot, whatever we just plotted, this is the plot of GMAT scores. So this GMAT scores, as we can observe, it is not normal, perfectly normal distribution. It is slightly towards negative or the bottom of the graph. So we can say it is not normally distributed initially. We are going to assume it is normal only. The first data whatever we calculated in this method is a randomly generated value. This I did not mention it explicitly, but this formula or this function produces random elements. So some random numbers, 20 different values, some random elements of 100 different values is produced. This random value, when we check whether it is normally distributed, it is in fact normally distributed, because in nature any randomly occurring event will become a normal distribution. So in any naturally occurring data we take, if that is going to be treated as random, then there is a higher chance of that being normal. That is what we were able to observe in this plot as well. Okay, just a side note, we can make a note of it. Okay, now let's proceed proceed towards a distribution function and derive some insights based on our data. So for that example, we are going to assume a problem statement. So in this case, there are some college entrance exam results which we are going to assume it is a normal distribution, and they have given the mean score and standard deviation of 15.2. Now the question is, what is the percentage of students scoring 84 or more in the exam? So now we have to calculate the percentage of students who has scored more than 84. So this particular mean and standard deviation is going to help me in creating a normal distribution curve. And in that value, say I want to calculate for students of score who has scored more than 84. This is the mean value, this is the standard deviation. And since we know the total area under curve is 1 and I want to calculate more than 84, I am actually subtracting the area under curve till 84. So what it will do, when I subtract 1 minus 84, it is going to give me the result of greater than 84. The percentage of students scoring greater than 84 will be provided by this formula. So similarly, there is another example. I have some random data captured here, data from this data. If at all, this example is to just compare with this particular solution and problem. In this case, I have already been given with the mean and standard deviation. Suppose I was not given mean and standard deviation, then we will have the entire data provided. From this data, we will calculate the mean and standard deviation using these formulas. Once these are calculated, suppose I want to understand the percentage of students who has scored more than 20. In that case, I will use this formula. 1, the total area is going to be 1. So first I will be calculating the area under curve for 20, the score 20. So norm.cdf, this is the cumulative distribution function, norm.cdf of 20, mean, standard deviation. So this will produce the value of, so this norm library was not imported, it is actually present here. Let me execute this and import. Once it is imported, I will execute this line again. So it says 82% of students, or the marks whatever is here is greater than 20. That is the understanding we can derive from this distribution and the distribution curve. Okay. So now it is a direct opposite. There is a direct inverse function, what we saw it as PPF, point percentile function. So what point percentile function will be helpful for? Say I want to know how much is 95%. Like how many students have scored, or the number of students that is scored 95 percentage of mark. So the area under curve is given now. We are given with the area under curve and we want to calculate the x-axis in this. The same, we are given some mean value and some standard deviation. So once when you calculate this, this is going to give me 64. So 64 number of students have scored 95 percentage of marks. So till 0 to 95% of area of the curve, 64 number of students has occupied the total area. So this is the understanding of PPF function. Okay. So there are still theoretical contents which is given in the references link. You can go through the CDF and PPF functions, which will give a even better idea.